In this video, we'll show you how to create a custom PCB to connect Yoctopuce devices. First, extract the Yoctopuce library for DipTrace, which contains 3D models and footprints for all Yoctopuce devices. Once extracted to your disk, you can start DipTrace and select the PCB layout tool first so that we install the Yoctopuce library in it. First you go to Library Setup and then you will install the component library with the file with extension ELI and the patterns, which are the PCB footprints. Eventually we'll also set up the search path for the 3D models of Yoctopuce devices. The 3D models are part of this library you've downloaded into Model 3D subdirectory. Now, as you can check, if you select the user components, you'll see all Yoctopuce devices available in the list. Okay, now we can start by drawing a schematic using the Schematic capture tool. First, we'll select the Yoctopuce devices and pick them and place them on our schema. Here we'll put a USB hub, we'll put two Yoctometeo devices to measure humidity and temperature at two different places, and we'll also add a power relay to control a vent system. As you can see, if the device doesn't come oriented the right way, you can turn it using the right click and rotate or press the R shortcut. We'll also add a wattmeter, and as we'll show you here, you can also rotate the device before placing it, pressing the space bar. Now we have selected all Yoctopuce devices. If you need standard connectors, wired to board, things like that, you'll find plenty of them in the DipTrace library. Often they are numbered with the manufacturer part numbers, so you have to browse a little bit through them to find the right one. Now we can start connecting the devices together. So remember, here we are just in a schema for now, so these are just logical wires to connect stuff together. Don't worry if the connection don't look nice immediately, it's very easy to fix them afterwards. We've connected the first device, now we connect the second one. As you see, sometimes the wires don't come in the right order, so you may have to get some crossing. It's not a problem. At this point, it's just a schema, so wires can cross in a schema without making a shortcut. Again, sometimes you need to edit a little bit the wire to make it look good. Third device to connect. So here it's just buses, we don't have to think a lot for connecting them. Then we connect the power socket and eventually the fourth device. Now we have connected all four sensors to the USB hub and the power socket. It's time to save our work, give a name, and this is just to save the schema for now. Now we can convert the schema into a PCB. There is a function for that, convert to PCB. And you can apply rules later on, but now we'll keep it simple. And here you see the footprints of the Yoctopuce devices corresponding to the device you have selected. So we'll pick a grid of 1 millimeter to start positioning the devices a little bit nicely. So for instance, we'll put them, the Meteo next to each other, closely to the hub, put the connector for power on the top, put the relay on the right, and put the wattmeter on the left. Now the blue line that you see are where you're supposed to put the connection between the pads based on the schema. DipTrace knows that you have selected to connect the devices in the schema and will help you to draw tracks. So for drawing track, I've selected a smaller grid and I'm going to use the root manual function to draw tracks from one pad to the other. And I'll have to avoid areas such as screws, because I don't want to create a shortcut when I place the screw to hold my devices. And I connect one pad to the other. There is an auto-routing function in this software, but you can try to play with it, but usually I don't like a lot auto-routing because it makes funny stuff with power connections going to all directions. So usually I prefer to do the routing. If a track doesn't look nice, like it's the case here, you can use this tool to edit tracks and adjust their position. At this point, it's important that tracks don't touch each other, otherwise they will make a shortcut. And it's also nice to keep them properly aligned together. We have connected the first device. Now we'll have to repeat the operation with other. As you can see, the device was not well aligned, so you can still move devices a little bit. You'll see that the track move along a bit, but this can create shortcuts, so be careful to edit the track afterwards if you move a device. Now, we're turning this device as well, since it was not in the right orientation, and we'll align also these others, as we see from the blue lines that the devices were not completely well aligned. Now, time to connect the second large device. We put the 3 wires. You'll see that for the first one it's going to be a little bit tight. Don't worry, we'll connect it, and again we can move the track afterwards. Now we want to connect the power socket to connect the hub power supply. So we'll draw track as before, but in this case we'll be looking to create larger tracks. Also we have to pass some obstacles, so as you can see, by pressing space while drawing a track you can change a little bit the way angles are done when you draw the tracks. So we make an approximate track initially and we'll fix it afterward to make it nicer. But this time I'm not going to keep the tracks too close to each other because I'm going to change the track width at the end. So first I'm fixing the track to make them line up properly, and then I'm going to select the track, right click and choose properties, and here I can change the track width and apply it to the whole net. So as you see in here, the first net is now thicker. I repeat the operation 1 millimeter to the selected net, and now I have 2 tracks which are thicker. It's best to use thicker tracks when you have more current going through them, like 1 amp or something like this. To connect the last 2 devices, I'm going to use the other side of the PCB, the bottom side. I can have track on both sides of the PCB, and this makes it much easier to do routing and avoid tracks that cross each other. So you see, in this case it's very simple. I can use straight line. For the second one, I still have to go around the power socket pads, but it's still easier. I can have one track going between the two, and the other I just have to go around. I just have to figure out how to get my wires properly, and I'll fix them afterwards using the track edition. Now we are ready to turn back to the top face, have a look at our PCB, and now we'll check that there is no short circuit and that we have routed all lines. So there are 2 check functions: design rules and connected nets. This will tell us in case the PCB doesn't match the schema or if there is a shortcut somewhere. Next step, we'll have to draw the PCB outline. For now, we didn't tell how big our PCB was going to be. So for this, I'm selecting a bigger grid, like 5 millimeters. I'm drawing some outlines, rectangular for now. As you see, I intend to split my Yoctopuce sensors away from the main parts, so I don't worry about the device being a little bit bigger than the PCB. I can adjust afterwards the line of the PCB just by moving the corners. You can also make more sophisticated shapes if you need, for instance, non-rectangular boards. That will work as well. Okay, looks good. Now it's time to have a 3D preview of our board. So we use the 3D visualization feature. DipTrace shows you that he has found all the models needed to make a 3D rendering of the board. And now you can see what the resulting product would look like. You see the board-to-board connectors between the PCB and the Yoctopuce devices, and you can see that there is no conflict. There is space for all devices, so it looks like our assembly is good. Now time to save. So this time we save the PCB itself. Before it was the schema, and now we can order the PCB. You can select how many PCB you want to order. Suggest 2 initially when doing your first order. There can always be mistakes, and as you see, the price will change based on the quantity. You can also change the turn time. Shorter turn time can get very expensive. So as you can see here, the price goes from $60 to $80 when going from 5 days to 4 days. So usually 5 days is a good trade-off. You just have to enter your address, company name, and that's it. The software will automatically ensure that the PCB manufacturer gets the right data to produce your PCB. After that, you'll get an email with your confirmation. You pay by PayPal, and a few days later, you receive your PCB. Now, to assemble the PCB and the Yoctopuce devices, the best way is first to put all the spacers that will hold together the PCB and the devices. So it's simple screws. These are the screw and spacers sold under the name Fix 2.5 on Yoctopuce shop. And then you will be able to put the board-to-board connector that will connect together the PCB and the device. So first connect the board-to-board into the device, hold it vertically, and come with the PCB so that both fit together. If you screw then the device to the PCB, the connector will not move anymore. Once you'll have put all your devices, now you can start the soldering. So always start by putting flux. Flux helps tint to wet well the contacts and to avoid creating bridges. You put the soldering iron on one side of the contact and you come on the other side with the thin wire to produce 4 nice solder points. Same process on the other side where components are located. So there you have to make sure you don't touch other components with the soldering iron. Start by putting flux as before and then come with the soldering iron and the thin wire on the other side.